In this lesson, we're going to look at how an electroscope works and how to charge objects. An electroscope is essentially a piece of metal that ends with two little pieces of foil at the bottom and then in some kind of casing to keep the wind and other things away.
Now watch what happens when I bring this rod close. You can see the leaves separate. So what happened here? Well, first off, note that the electroscope is neutral. It has the same number of protons as electrons. But when we bring a charged object close, in this case a negative rod, those negative electrons want to get as far away from that negative rod as possible. And because they are free to move in a conductor, they will scoot on down here to the bottom and collect in the leaves. Now the leaves themselves are quite light and able to move, and so because they're now both negative, they will separate like so. So how can we charge an object by contact? Well, the electroscope's a nice example of that, because when we bring the negative rod close, again, those electrons want to slide down away from that rod. The same would be true if this is positive. They just move up and the positive would be down there. And so by contact, when the rod or any charged object touches another object, a neutral object in this case, well, these electrons sense the positive protons that are left behind here when the other electrons have moved to the bottom. And so they'll steal a few electrons from the charged rod, which has lots of extra electrons to begin with. That's why it's charged. Now, when you move the rod away, we can see that we have more electrons than we have protons, and so the entire object now is charged. It's not just polarized like before. So we've charged an object by contact. So lastly, we can charge an object by induction. So again, I'll use a negative charge, bring it close. In this case, though, we don't touch. That pushes the electrons down to the bottom as before, polarizing the metal, which means we just put the negatives at one end and leave the positives at the other. But now, instead of touching with our charged object, we bring another neutral object, in this case my finger, close. And I will touch the electroscope with it, and some of my loosely held electrons will then be attracted to those positive charges, leaving the overall device negatively charged in this case. And so no charged object touched another object in this case, just two neutral objects did, but we were still able to induce a charge by bringing a charged rod close. Now, all this is true for positive too. This could all be opposites, in that this could have been a positive rod, which would have just meant that everything sort of moves in the opposite way. But nonetheless, there's nothing special about using a negative rod to start here. So we've seen how an electroscope works. We've seen how to charge an object by contact and by induction. And lastly, you can charge an object by friction, but you've all seen this before at a birthday party. When you rub a balloon on your hair and stick it to the wall, you've charged that balloon by friction. So now let's see how we can make our own electroscope, and you can try some of this at home.
Hello and welcome to Sweatsuit Science. I am Andrew. Today we are going to build an electroscope. An electroscope is a device that can detect charged objects. We're also going to look at how we charge objects. There's three ways: friction, contact, and induction. To build our electroscope, we will need a glass, a pair of scissors, some tin foil, tape, a paperclip, and a piece of cardstock. The cardstock can be anything. This is an old file folder, as long as it doesn't fall through the glass. So take your paper clip and you're going to bend it into an S shape, like so. And then you'll take one end and And just make it so that you can poke a hole in your cardstock. Carefully do that. And then pull that through so that you can see that that bend is through, and you just have the hook on the bottom. You'll want that so that you can take a little bit of tape and secure it. So put that down. It doesn't really matter how this looks. It's more that you just need a hook on the bottom like that. How you want to bend the top is really up to you. So now that we have that, you can see that that should sit on the glass like that, and that you have a hook on the bottom. Now we take some tin foil, and I'm going to cut a strip out. I don't know, about 6 to 8 centimeters long, and then cut it in two so that you have 2 leaves. Then you will take your hook on the bottom and push one leaf through. I like to do this one at a time because when I've tried to put them both on at the same time, they sometimes will stick together and we won't get the results we're looking for. So push that through and let them sort of dangle like so. And just again, make sure that they're not stuck to each other, that they are just hanging side by side. Once you place that back on your cup, you now have an electroscope. So I'm going to charge up the balloon negatively. The balloon will steal some negative electrons from my hair, and I'm going to bring it close to the neutral electroscope. The electroscope has the same number of protons as electrons, but as we saw before, we can redistribute them by bringing the negative balloon close. And so that pushes those negative electrons down the metal into the leaves, which makes them separate. Thanks a lot for watching, and we'll see you next time.